Welcome to LLMs as Operating Systems, Agent Memory, built in partnership with Ladder. In this course, you explore and build memory for AI agents. You also explore the idea that an LLM agent can manage its own input context window, essentially acting as the operating system in an AI application. Your instructors for this course are two of the authors of the influential paper MemGPT toward LLMs as Operating Systems and are experts on this topic. Welcome Charles Pecker and Sarah Withers.
Thanks for having us.
Thank you.
If you've taken some of our earlier courses on prompting LLMs via an API, you might be familiar with the idea that although LLMs can do amazing things, they don't have persistent memory and that you need to manage its memory explicitly.
Indeed. The common example is if you make one API call to say, hello, my name is Sarah, and then make a separate API call to ask, what is my name? It won't remember. If you want it to remember, you have to pass in the conversational history again with each additional API call.
By including information in the prompts, also referred to as the input context, you can give the model additional information that it can use to generate its output.
Exactly. And what is in the context window really determines the behavior of the LLM and your application. For example, a chatbot application has conversational memory that stores earlier exchanges in the conversation. You may also want to track personal facts or names over time, or keep track of tasks. You may want to share information between LLMs in different agents. In RAG applications, you retrieve relevant information from an external data source and introduce it into the context of the LLM.
So an LLM can make use of any information that is included in its input context to generate its response. But the space available in the input context window is limited, and using longer input context also costs more and results in slower processing. So managing this in-context information, what to include in this input context, is really important. The MemGPT paper described a novel approach to this to let the LLM manage it. If you're familiar with the concept of virtual memory from computer systems, there's a nice analogy that MemGPT uses to explain this idea. But if you aren't familiar with that concept of virtual memory, don't worry about it. This course will still make sense and still be useful to you. But Charles, why don't you explain that analogy?
Sure. So we like to think of the context window like the virtual memory on a computer. Your computer thinks it has a really large memory, much bigger than the physical memory it actually has. Specifically, it has a very large virtual memory. When it tries to reference a virtual location that is not present in physical memory, the operating system will first make room for it by moving a block of information that is in physical memory out to disk, preserving any changes in that block, and then fetching the new block of information with the referenced address from disk back into physical memory. Similarly, you can think of the context window of an LLM as analogous to the physical memory. In our system, an LLM agent includes the role of the operating system and makes decisions about what information should be included in the context window.
AI agents can use an LLM for planning, use tools, and make decisions, such as deciding to stop or continue a task. A similar approach also lets an AI agent manage its own memory.
To support memory management, the agent is given a section of the context window for long-term memory, which the agent can write to. The agent is given tools to access external storage, such as databases, to create a larger memory store. Combining tools to write to both its in-context and external memory, as well as tools to search external memory and place those results into the LLM context.
So in this course, you'll get to put these ideas into practice. In these lessons, you will build an LLM agent that can edit its own memory from scratch. This will ground you in the basic ideas of LLM memory management. Next, you'll go beyond the basics and learn the key concepts from the MemGPT paper. Then we'll introduce Ladder, an open source agent framework in which agents have the tools and information to manage the context window. You can use Ladder not only to build MemGPT agents as described in the original paper, but also go beyond the research paper and build agents with more advanced types of memory. In multiple lessons, you'll create agents and explore the details of how memory is built. You'll put this into practice by building a custom task memory. You'll use this knowledge in applications including your own research agent and an HR multi-agent application where agents share memory.
We want to acknowledge some of the people who helped create this course. Professor Joseph Gonzalez, who is a UC Berkeley faculty member and a Ladder advisor, the Ladder team, and from deeplearning.ai, Jeff Lodwick. The ideas here are really exciting. Letting an AI agent manage its own memory is a novel and powerful technique, and it provides a powerful infrastructure on top of which to build many applications. Let's go on to the next video to start learning about this.